Hello, welcome to today's lecture. Math 1B, we're going to continue chapter 7. 7.3, page 1. After we finish 7.3, I'm going to answer your questions about our midterm. Perfect. So let's review what we learned so far. Review on chapter 7. So we learned that if we have like functions inside the integral that are very hard to handle, we learn different techniques to work with those integrals. So first of all, remember that we have some nice integrals, like the integral of constant k dx, which is defined as kx plus constant of integration. So if you have the integral of dx, it means that it is 1 times dx. So the integral of 1 times dx is equal to the integral of dx, which is equal to, your k is equal to 1, it is x plus c. If you have, for example, integral of x to the n dx, if you have a power function, it's going to be x raised to n plus 1 over n plus 1 plus constant of integration. If you have, for example, integral of sine x dx, this guy is equal to minus cosine x plus c. If you have, for example, integral of cosine x dx, it's going to be sine x plus c. If you have, for example, integral of e to the x dx, you know that this is in general is e to the x plus c and so on. Then we learned that, okay, sometimes we have integrals and we don't know how to handle those. If you have an integral with more tricky functions inside the integral with different exponents, we have to use what we learned in pre-calculus using three identities. For example, we learned that, these are just to recall, if we have the integral of cosine x raised to the third power dx, this is cosine to the third. I don't have any integral with exponent 3. So remember, we just tried to use U-substitution by writing this integral this way. Cosine squared x, cosine x dx. From pre-calculus, you know that cosine squared is 1 minus sine squared. So this is 1 minus sine squared x times cosine x dx. We learned about U-substitution before. So since I know that this sign has exponent 2, it's better to take u to be sine of x. So U-substitution, u is sine of x, and du is cosine x. Since we took the derivative with respect to x, we put dx next to it. So now you can rewrite your integral in a simpler format. What format? It's going to be integral 1 minus u squared. My sign is u, it has exponent 2. So 1 minus u squared, and cosine x dx is du, using U-substitution. Of course, I know how to take this integral. This is very similar to my power function. The integral of 1 du minus the integral of u squared. The integral of 1 is u plus constant of integration minus, this is my power function, a third, u to the third, and since I have just two indefinite integrals, I put one constant of integrations here. The original integral is in x, so the final answer must be in x, not u. So since u was sine x, just substitute that here. We get sine x minus a third sine to the third x plus constant of integration. So in 7.3, we're going to learn a new technique. Let me list them for you. Then you have crazy looking integrals like this. Consider the following integrals. For example, you have the integral of square root of 9 minus x squared dx. Suppose you have the integral of, for example, square root of 4 plus x squared dx. Suppose you have the integral of square root of x squared minus 25. When we have integrals like this, so you have one square root, 9 minus x squared, square root of 4 plus x squared, square root of x squared minus 25. We cannot use U-Sub. Why is that? We cannot use U-Sub. Take a look at the first integral. You might say, okay, I have the integral of square root of 9 minus x squared dx, and I want to use U-Sub. So since I have a quantity inside the radical, I want to take u to be 9 minus x squared. So du is minus 2x dx. Do I have negative 2x next to dx? No. Am I allowed to multiply x and divide by x? Unfortunately, no. So, since we don't have x next to dx, we cannot use U-Sub. We cannot use U-Sub. So, what's the remedy for that? We're going to use trig sub. For all of these, what we're going to do, we're going to apply trig sub. So, what's the substitution that I need for each of these cases? So, let me write a general constant here for you. A squared, and a squared. In the first case, the substitution is going to be a sine x. So your substitution, x is a sine theta. Let's write it in theta format. So wherever you see x, you substitute that with a sine theta. And dx is now a cosine theta. Again, if you have the integral square root of a squared minus x squared. Guys, sign in the middle is important. The ordering is important. You have a squared minus x squared. the substitution, the trig sum is going to be x equals to a sine theta, and the derivative of dx is a cosine theta d theta. The next one. If we have the integral of a squared plus x squared, a squared plus x squared. In this case, the substitution that we need is a tangent theta. So x is equal to a tangent theta, and dx is equal to the derivative of tangent. So remember that then you have tangent theta, and we're taking the derivative of tangent. Tangent is sine divided by cosine. So you can apply quotient rule. The derivative of sine is cosine. Cosine times cosine is cosine squared. Cosine squared minus the derivative of cosine is negative sine, so you get plus sine squared divided by cosine squared of theta. This is 1 over cosine squared of theta, or since we define cosine, 1 over cosine to be secant, you get secant squared of theta. So the derivative of x is a times secant squared of theta d theta. And finally, if you have your integral to be square root of x squared minus a squared, then you use trig sum x to be a secant of theta. There we go. Let us take the derivative of secant. Secant is 1 over cosine theta. If you apply quotient rule, it's going to be sine theta divided by cosine squared of theta, which is sine over cosine times 1 over cosine, which is tangent times secant. Tangent theta times secant. So dx, the derivative of x, is now secant tangent, don't forget to put a in front of it, d theta. Perfect. So we are on page 1. We're going to do the first example. This example says, very well, we have the integral of square root of 9 minus x squared divided by x squared dx. Okay, perfect. What do we have? We have square root of 9 minus x squared. First, check to see if you can apply U-sub or not. So first, try U-sub before using trig sum. If you had, for example, something like this, the integral of square root of 9 minus x squared x dx, then it's easier to use U-sub. Okay? Your first and base step is try to using U-sub. Of course, you don't have x dx here, so U-sub doesn't work for me. Since we don't have x times dx, we cannot use U-sub. So we don't have any other choice but using trig sum. Now let us try trig sum. Okay. So I memorized these formulas before. I know if I have square root of a squared minus x squared, my x can be replaced by a sine theta. So since we have square root of 9 minus x squared, or square root of 9 is 3 squared. 3 squared minus x squared. We use 3 sub x is equal to a, which is 3 sine theta. I already know that dx is equal to 3 cosine theta d theta. Substitute everything you have into the original radical and inside the integral. So you have the integral square root of 9 minus x squared divided by x squared dx. This guy can be written as the integral radical 9 stays the same minus my x is now 3 sine theta. So 3 sine theta. 3 sine theta raised to the second divided by x squared. X is 3 sine theta. So 3 sine theta raised to the second. So we have to raise it to the second power times dx. My dx is now 3 cosine theta d theta times 3 cosine theta d theta. Okay, let's try to see what's going on here. So I'm going to write down here. This is equal to the integral. Inside the radical, I have square root of 9 minus 9 sine squared theta divided by, if I square this, I get 9 sine squared theta, and I copy down 3 cosine theta d theta. Inside the radical, I'm going to factor out 9 to simplify this radical. So this is equal to the integral square root of 9, 1 minus sine squared of theta divided by 9 sine squared of theta times 3. To simplify this, we have 3, we have 9, so we get a third sine squared of theta cosine theta d theta. So this integral can be written as the integral of square root of 9 square root of 1 minus sine squared is cosine squared divided by 3 sine squared theta cosine theta d theta. Square root of 9 is 3 divided by 3 is 1. So you can cancel out this. This is equal to integral. So square root of cosine squared is cosine theta divided by sine squared theta times cosine theta d theta, which is equal to the integral of cosine squared divided by sine squared d theta. This is the integral of cotangent squared, which is equal to negative cotangent theta plus constant of theta. We have theta as well, minus theta plus. Leave it as it is for now. I'm going to explain how to convert that into x. So let me erase this part and explain how we can convert theta into x. So let me rewrite this for you. So x is equal to 3 sine theta, dx is equal to 3 cosine theta, d theta, and we saw that this is now equal to the integral of 9 minus 9 sine squared divided by 9 sine squared times 3 cosine theta, d theta, and we saw that this is equal to the integral of 3 times 3, so we have sine cosine squared of theta, d theta over sine squared of theta, which is the integral of cosecant squared of theta minus 1 d theta, which is equal to negative cotangent theta minus theta plus c. Okay. Now, guys, we're going to get back to pre-calculus. Remember, recall, in pre-calc, we define sine, cosine, tangent, and cotangent as functions using a right triangle. If you have a right triangle, theta, and suppose your radius or the hypotenuse is 3, and suppose the side which is in front of theta is x, you can use Pythagorean Theorem to find this length. 3 squared is equal to the question mark here, 3 squared is equal to x squared plus question mark squared. Question mark squared, the missing length, is equal to 3 squared, which is 9, minus x squared. So this length here, as the question mark, is equal to square root of 9 minus x squared. This is square root of 9 minus x squared. So suppose you have this right triangle. Okay? How did we define sine of theta? The sine of theta, if you get back to pre-calc, is defined as x divided by 3. Cosine theta was defined as square root of the adjacent length, 9 minus x squared, divided by 3. Then we divide these two to define tangent, flip tangent to get cotangent. So, your tangent, which is defined as sine over cosine, is x divided by square root of 9 minus x squared, and cotangent theta is the flip of tangent, which is square root of 9 minus x squared divided by x. Very good. Do I have my cotangent here? My cotangent is defined as square root of 9 minus x squared divided by x. So I just substitute that here. This is equal to minus square root of 9 minus x squared divided by x minus the theta. What is theta here? Theta, you can use this formula or you can use this formula. Both of them are acceptable. Theta is equal to inverse sine of x divided by 3. I'm going to replace that here. Inverse sine x divided by 3 plus constant of integration. Very well. Next example for you. We are on page 2. Page 2. Example. Okay. So what do we have here? We have the integral of dx divided by x squared times square root of x squared plus 4. So let's get back to the beginning of the class and we define the integral using trig solve. If you have the integral of square root of a squared plus x squared or x squared plus a squared dx, x is a tangent of theta. So the derivative of x is equal to a times secant squared theta d theta. So let us identify a here. A squared is 4. A squared is 4. So your a, the hypotenuse is 2. There you go. Okay. I have all the information that I need. I know a is 2. Tangent theta. Dx is 2. Secant squared theta d theta. I'm going to replace everything that I have by the new information from trig solve. Okay, I can rewrite my integral this way. I get the integral of dx, which is 2 secant squared theta d theta divided by x squared, which is 2 tangent theta squared, square root of 2 tangent theta squared plus 4. Okay, let us continue. We have the integral 2 secant squared theta d theta divided by 4 tangent squared theta square root of, here I have 4 tangent squared, I can factor out 4 tangent squared theta plus 1. Remember that tangent squared theta plus 1 is sine squared over cosine squared plus 1, which is equal to sine squared plus cosine squared, which is 1 divided by cosine squared or secant squared of theta. So this integral can be written as the integral of 2 secant squared theta d theta divided by, let's simplify this, so I put 2 here, down, 2 tangent squared theta, and the square root of 4 is another 2 times square root of secant squared theta. This guy can be written as secant squared theta d theta over 4 tangent squared theta, and square root of secant squared is secant theta. I can simplify this fraction by cancelling out secant and the exponent. This integral is equal to secant theta d theta over 4 tangent squared theta.
Professor, I have a question. I'm sorry.
Okay, perfect. So let us simplify this integral, see if we can get something out of it. The integral, so secant is defined as 1 over cosine. 1 over cosine theta divided by, on the denominator I have 4 times, tangent is sine over cosine, so I get sine squared divided by cosine squared theta d theta. This part can be written as 1 over 4, the integral, so I took out 1/4 and wrote it outside the integral. Here you have 1 times cosine squared, which is cosine squared, divided by cosine times sine squared. So here I can simplify this more. I'm happy I can eventually use U-sub. This can be written as 1/4 integral of cosine theta d theta divided by sine squared theta. Very well. Now you stop to think out your integral. I have sine squared on the denominator, and if I take U-sub, by taking U to be sine theta, du is cosine theta d theta. Hey, I have cosine theta d theta on the numerator. Why not using U-sub? So let us apply U-sub here. This is equal to 1/4 integral cosine theta d theta is equal to du divided by u squared, which is super easy to handle. This is 1/4 integral u to -2 du, which is 1/4 -1 u to -1 plus constant of integration, or 1/4. Guys, this is not inverse, this is the exponent. So you're going to flip that and write it 1 over u plus c. We're halfway done. Almost done. Okay. So we know that x is equal to 2 tangent theta. So let's get back to our right triangle, and remember that when we define tangent, so this is your theta, the tangent of theta is defined as the opposite side divided by the adjacent side. So what's given? X divided by 2 is given. X and 2. That's the definition of tangent. What I did, I divide both sides by 2. Tangent is x over 2. So I have my x, the opposite side, the side in front of theta, divided by the adjacent side, which is 2. So what is your radius? What is the hypotenuse? It's equal to square root of x squared plus 2 squared or 4. So let's see. What do I have here? I have negative a fourth times 1 over u, and u is sine theta. So this is negative a fourth times 1 over sine theta plus c, which is negative a fourth. Sine 1 over sine is defined as cosecant theta, or you can just leave it as sine, and your sine is defined as x over square root of x squared plus 4. So if you flip it, because you have 1 over sine, you get square root of x squared plus 4 divided by x plus constant of